screen is visible, right?
Yeah, it's visible.
Okay, great. So, welcome everyone to today's online webinar. It's 10th meetup, online meetup organized by both Green Data Innovators Meetup Group and also Orlando Power BI User Meetup Group. Today we are going to talk about using T-SQL functions for advanced analytics. In this guide, we'll explore how T-SQL functions can be seamlessly integrated with your data workflows and enhancing your ability to perform complex calculations. And this session is going to be done by one of Microsoft MVPs, Tural Suleymani. In next minutes, Tural Suleymani will give the necessary info about himself, but I would like to talk a little bit about our session schedule. So this is what I'm doing introduction in 5 minutes. And after 5 minutes, Tural Suleymani will have his presentation. During the presentation and also at the end of the presentation, we'll have Q&A session. You can type your questions in chat box or you can ask your questions. And as I mentioned, keynote speaker, today's speaker is Tural Suleymani, who is a Microsoft MVP. And a little bit about meetup rules. If there is any shareable materials related to the topic in today's meetup, I'm going to share all these materials with you. We have Q&A session, and also this meetup is subject to recording and also sharing. A little bit about our next speakers. In next months, in November and December, I'm going to hold meetup sessions with the participation of Keteva Potova, who is from Georgia, and also with Katerina Mladenovskaya, who is from North Macedonia. And last point, this is my contact details. If you desire to present or to deliver a speech, you can reach me using this email address or this phone number, and we can organize a meetup with your participation. Now here, I would like to stop sharing my screen, and I would like to deliver stage to say our speaker, Tural Suleymani. So Tural, this is your time. So please feel free and to go on. Thank you.
Yeah, thank you, Gal, for the introduction. Yeah, let me share my screen. I hope you all now able to see my screen. Yeah.
Yes.
First of all, thank you very much for joining, everyone. Today, as Ilgar mentioned, we are going to talk about using Transact SQL functions for advanced analysis. I'm going to write not so hard SQL queries, but the purpose here is to show you, to demonstrate you the real value of using Transact SQL functions for your advanced data analysis, okay? As Ilgar mentioned, I'm Microsoft MVP, and I'm also author of Hands-on Microservices with JavaScript book. I am first Microsoft MVP from Azerbaijan in .NET C#, and also I am 3 times C# Corner MVP. I have a course on Udemy called Apache Kafka for Distributed Systems, and I have 2 YouTube channels in Russian and English languages. You can follow me for more deep video tutorials related to Transact SQL, C#, Apache Kafka, GraphQL. Actually, I'm a backend engineer, but in my practice, I have around 10 years of experience using Transact SQL in my daily basis applications in my practice, let's say. Okay? And also, these are my social media account where you can reach me and follow me for more deep tutorials, let's say. I'm actively sharing videos, articles on my LinkedIn, Medium account, and etc. Okay. Here in our agenda, we have 4 main subtopics. First is a brief overview of Transact SQL and its role in SQL Server. I will try to demonstrate the overview, the basic understanding related to Transact SQL. And second, we'll talk about importance of advanced functions in Transact SQL, especially for data analysis. These 2 sections are going to be theoretical. I know most of you may not love the theoretical sections, but to gain more deep understanding, we should learn the theory side of Transact SQL and functions. And the third and fourth is going to be practical, where I will show you how to build your custom Transact SQL functions for data analytics and also built-in functions for data analytics. Okay, now let's start from brief overview of Transact SQL and its role in SQL Server. So first things first, I want to show you why Transact SQL functions for advanced analysis. And actually, what is Transact SQL? Transact SQL is just an extension for SQL. It is developed by Microsoft and Cbase. It is a primary language for the database programming, especially in SQL Server databases. You can write any type of complex queries using Transact SQL. You can build your complex database operations, advanced analytics using Transact SQL, like views, functions, stored procedures, and etc. Transact SQL is not just a querying language, but it also has procedural programming features like if, else, while, begin, end. If you are a programmer or if you know how to write simple programs, these operations, these code blocks we're actively using in programming, and using these code blocks, you can easily write any type of complex business logic in your Transact SQL queries directly. We have cool error handling mechanism in Transact SQL. This error handling helps us to handle all sort of errors, to not to throw any type of internal exceptions to our user. And also, as I mentioned, Transact SQL have possibility to program something, to program your functions, store procedures, and we have parameters and variables that Transact SQL supports, declaring and using variables and parameters, which allow for dynamic query writing and more flexible scripts. And also at the end, I really love these subtopics of Transact SQL, especially the related of transaction management, store procedures, and functions. And if you're a software developer, you may actively use these two tools, especially functions and store procedures, in your applications. Okay? And in the context of advanced analytics, what can Transact SQL provide for you? Transact SQL's extended capabilities allow for complex data transformations, aggregations, and real-time analysis. You can write any sort of complex queries and encapsulate these queries using your views, your functions, your stored procedures, and even the business logic you write in your programming language side, you can completely move it to Transact SQL. Of course, it depends from your cases, but you can completely implement all sort of any complex logic in your Transact SQL side. So Transact SQL is like query language plus with programming possibilities. Okay, great. Now the second part is importance of advanced functions in Transact SQL, especially if you love data analytics. So advanced functions in Transact SQL. Of course, in our today's session, I will demonstrate how to write your custom Transact SQL functions and also built-in functions. In most cases, we don't need to write all these things from scratch because we already have built-in cool Transact SQL functions, 100 of them, and they will make our life really easy when you deal with complex data analytics queries. Like, for example, we have sum, AVG, count, group by. We have windowed functions like row number, rank, dense rank. We'll also talk about that. We have the transformation, data transformation, including resharpening tables with pivot, unpivot. We also have a more complex query writing code blocks like case when, if, call is. They allow us for more sophisticated conditional logic within queries. They are enabling flexible data transformations based on multiple criteria. So long story short, Transact SQL functions allow you to write your complex queries only one time, to not to repeat them and easily reuse them. If you have complex data analytics query, if you don't want to write everything from scratch, you may forget to even how to write this complex queries for the second time, then you can easily wrap all your complex queries into Transact SQL functions, views, and reuse them. Now this third part, I guess I also really don't like theoretical sections, truth be told. So I hope this third and fourth section will be really interesting for you. So in this section, I'm going to demonstrate building custom Transact SQL functions for data analytics. This is going to be a practical section. So let me open our SQL Server Management Studio. Of course, you can use any other IDE that supports Transact SQL, but for me, the easiest and my native SQL query writing IDE is going to be Transact SQL Management Studio. And I will use AdventureWorks 2019. Of course, you can use any other database. In this case, we are just using it as an example, but the things I'm going to explain are applicable all sort of databases, tables, etc. Okay? So first things first, let's connect to our AdventureWorks. And here we have special table on the sales schema is going to be sales order detail. I am providing alias for it. So as you can see, this is detailed information of sales order. And we have special offer ID, which refers to another table. So as you already know, we'll use a simple inner join to our sales special offer. Let's provide alias for it, and for the primary key of our special offer, it is called special offer ID. I will use my foreign key of special offer ID. This query is going to join our two tables. So when you deal with tables in database, you actually will deal with a lot of joins, because from the database perspective, we are not storing all this information in one single table. Instead, we are dividing this table using normalizations, forms, etc. to make a better database design. And we'll remove this star from here, and I'm just interested in for carrier tracking number, line total, and also max quantity from the special offer. Okay, so I have two columns from my sales order detail and one from max quantity. That's great. And as you can see, this is my query. As you can see, I'm going to add more and more filtration stuff, join stuff. So this query is going to be bigger and bigger. And I want, at the end, my plan is to reuse this query to not to write this select every time, okay? So what I want to do, as you can see from the carrier tracking number perspective and max quantity, we have a lot of nulls here. So I want to get rid of these nulls. That's why I'm going to filter it and to say that, okay, now what? Let's remove all these nulls and filter only not null values, and this condition is also applicable for max quantity. Okay, sorry, and is not null. Yep. That's good. Now we have the carrier tracking number, which is not null, and max quantity also not null. That's great. What I'm planning to do, I want to add more filtration from the business perspective. We are looking for line total with which greater than 1,000. So what I need to do, I need to provide line total. It would be better to provide the alias stuff. If you have line total in another table, it will conflict with it. So, and let's provide like this, and let's execute. That's cool. Now we have 392 rows. Okay, Now we have this sort of query, but as you already now this query is not a good query to reuse. For example, in my one business, in my one mm, analytical query, I need a line total which is greater than 1,000, but in another report, I need to retrieve line total which is greater than 10,000. So that means I just need to copy this like this, okay? So when you need to change, for example, you need to add, they asked you to add one more column like so that minimum quantity, you need just to duplicate this column for all sort of the same sort of queries. That's a big issue. That's a big problem. Say you have 10 select, you should just copy this min quantity column for all of your 10 queries. But how we can avoid this code duplication? How it is possible for me to not to copy this select statement and just reuse it? Okay, that's where we are using transact SQL functions. Transact SQL functions also allow you to use the same query but with different conditional data. It means now I may need greater than 1,000, but for the next query, I need greater than 10,000. Okay, I don't want to copy paste my code fragments everywhere, and that's why I'm just going to create a function. So below above your select, you should type create function. Mostly I name my functions with UFN prefix, and what we are planning to do, what's the purpose of this query, what's the purpose of this business operation. This is just retrieving information from sales order details. So get sales order detail info. This is really important when it comes renaming your function, because your function should describe the business. Okay, that's cool. And what I need to do, I need to provide some argument from my function. What is argument here? Argument means you want to get rid of the static values from your query. In my case, I may use 1,000, 100, 5,000. It depends from the business requirements. Actually, it depends from the reporting requirements. That's why I'm just going to provide this value from outside. Okay, so this line total is numeric. So let's call it just line total to match the exact column, and let's define it as a numeric value. And I should specify what type of information is going my function to return. So it is going to be, it will return tables, and let's return. That's how simply we are creating a function over our complex query. It doesn't matter if you have 4 joins, 10,000, it doesn't matter. Actually, you can wrap any sort of your select queries into a function. And let's reuse this value here. I'm just going to copy and paste it here, and let's create. So command completed successfully. Now I want to call my function. In order to call your function, you don't need to write everything from scratch. You just need to call the name of your function. Okay, I want to call it with 1,000, and maybe let's call it for another condition. Let's call it with 5,000. Okay, that's cool. Let's run it. Let's run them together. Okay, so you see, everything is working in one condition. I will get 392, and for another case, I don't know, 276. So this is how we are reusing our queries using Transact SQL functions. This is called table valued function. This is really important to understand, table valued function. The purpose of table valued function is to return the exact table. It doesn't mean that you should return all columns of your table. Even generated runtime information here, the more than one column, is going to create a virtual table in this case. So it doesn't matter if you are providing star here or if you are retrieving the exact columns that you need. You should specify that you're returning a table. Okay, that's from the table valued functions perspective. So you see, it's really easy. You just need to write your complex query, select query once, and wrap it to your function, and that's all. If you want to call it, just simply call the function name, and it will return all the information related to this select. That's cool, but how about doing the calculation stuff from the query perspective? In some cases, we need to aggregate our data. Let me just copy and paste it here. Come. And let me retrieve our data. That's cool. In my case, so you see I have duplicate carrier tracking numbers here. I want to get total sum of my line total based on carrier tracking number. Okay, so how it is possible for me to get it? Of course, in Transact SQL, you have built-in functions. Even you want to explore the functions provided by Transact SQL, you can open any type of database here. It doesn't matter. It will be automatically copied to all type of databases you're creating. Now I have the programmability section. It is applicable for all type of database you're creating here. And we have functions. So you see we have table valued function. Let me just refresh. And when I create my function, I'm just able to create it as an object here and to call it even after reopening SQL Server Management Studio. And we have system functions here. So you see we have aggregate functions, which is cool functions for your data aggregation, for your data analysis. We have datetime functions, we have mathematical functions, we have security functions, string functions. So we have more than 100 of functions in Transact SQL. They are built-in functions which you don't need to write everything from scratch. You don't need to write your own AVG, your own count, your own max, min. You can easily just reuse all these functions provided by Microsoft. Okay, that's cool. Now I want to, as I mentioned, I want to get the total sum of line total based on my carrier tracking number. That's why I will simply use the built-in sum function here. And what I want to do, I want to get total sum of line total column based on carrier tracking number. And I want to calculate only 5% of this line total. So in order to calculate line totals 5%, I'm just going to do like this. Okay, sorry, like this. That's simply what I am going to write here. This is a simple mathematical function. Actually, this is not a mathematical function currently. This is just a simple combination to get my result. But let's check if it is possible for us to get it or not. When I run this query, it will fail, of course, because we are using aggregate functions and it is not possible to aggregate data. You should specify the exact columns. You should group by these columns. Okay, so this is group by carrier tracking number, and we don't need max quantity right now. Let's just remove it. We don't want to group by max quantity also. So let's just simply run our query here, and here we are. This is our carrier tracking number, unique carrier tracking number, because we are grouped this information. So what's the problem here? The problem here is we have business, and this business requires this type of calculation in my another select queries. So what we can do, I want to write only one mathematical function, and I don't want to spread these code lines everywhere for all select operations in my case, because when we change this formula from 5 to 4, I must change in all my select statements. But I want to calculate it. I want to write this mathematical function once and just reuse it. Okay, so in order to write it to once, to not to repeat it, Transact SQL provides a scalar function for you. That's how we are doing this. Okay, so I will create another function, create function, and UFN get percentage. Okay, the get percentage will allow me to not just get 5%, but I will be able to provide any number from here. That's why I'm going to percentage number. It is going to be integer, and I'm going to return the scalar information. I'm going to return a primitive information rather than table. So that's how it looks like. What I'm planning to return, I'm planning to return, for example, decimal information or numeric information. It doesn't matter. They are completely same. And let's write like this, begin, end. Because we have some sort of calculation, and for the complex calculations, we need to provide begin end here. And I need to provide the line total information. Even using this function, I will be able to calculate any percentage for any column rather than line total. Okay, that's how I'm going to provide it at data as decimal. Let's provide like this. Okay, great. What I'm going to do, I'm going to declare a new variable which is going to hold the result of my calculation. Okay, as decimal 10 and let's do the simple calculation here. That's how we are going to set it. Set at result, we have our data. I will multiply it to provided data and divide to the 100. And let's just simply return at result. Even you can simply do it like this. Just remove all this stuff. You don't need this stuff. Just simply return. That's all. You see, I've typed only one single line for the calculation, and let me just execute it. Now I have get percentage functionality, and to replace all this stuff here, I'm going to provide my get percentage with so that line total, and the percentage amount is going to be 5. Now I am able to remove it from all my select statements. That's great, isn't it? So the dynamic result, let's call it dynamic result. It is going to be dynamic result, and let's just simply execute it. So this is not recognized because we should provide DBO here. And let's execute it. So we have the group by stuff here. We don't need to write the group by statement because we are simply moving all this operation to our get percentage. And let's provide the sum like this. Okay, let's run it. So invalid select statement, either aggregate function or group by closure. Okay, let's see what we can do here. Let me just simply copy this from here, and I'm just going to call it like this. And I'm going to provide, for example, 2,300. Okay, so I have two information here. First one is going to be for my data, and the second information for my percentage number. Okay, let's just simply call it, and here we are. We are able to retrieve this data. You can just simply replace this query to your apply. We can easily implement it using apply, or even using like this, we can simply modify it. But for now, I just want to call it column sales order detail carrier tracking number. Since something is wrong with carrier tracking number, let me just check, because sales, we don't have sales order detail carrier tracking number. Okay, because we are using it inside our from. Okay, no worries, that should work. Yeah, that's cool. That's how we are implementing our simple calculation base, because we are using the sort line total. If I want to provide carrier tracking number, I can easily do it. Okay, carrier tracking number, because I want to group by my carrier tracking number. So you should provide the group by functionality for your carrier tracking number, and that will be okay. Even for not grouping your data, if you don't want to group your data, you can just simply provide like this, and that's all. You have carrier tracking number and you have like this amount. Every time it will provide your line total to this function for all rows, and you will retrieve 5% of this data. Even I can easily change it to 34. So you see, that's 34. That's how we are easily implementing all these business complex operations, mathematical operations, analytic operations, and we can easily wrap it to Transact SQL functions, even to reuse it. Okay. That's cool. And the last one is going to be built-in functions for data analytics. What is built-in functions? As I mentioned, Transact SQL provides a lot of built-in functions. You don't need to write all sort of functions from scratch. Of course, depending from your business, you should write every operation that is related to your concrete business. But we have tons of functions which are applicable for all sorts of businesses. For example, sum, mean, max, average, etc. And we can easily use them for our any sort of function. So to demonstrate this, I'm just going to copy it to a new window. Okay, let's simply provide 1,000. Doesn't matter right now. Let me just execute this query. So the interesting thing here is when I want to write sum, the built-in Transact SQL function for my line total, when I execute it, as you know, it will fail because we don't have grouping, we don't have max quantity. Let's execute it. It will be possible for me to run this query without any issue if I am providing these columns, of course, because we should group by this. Okay, that's cool. That's working. The case here is I don't want to group my data, but I actually want to retrieve this information. This is also super simple using Transact SQL. In Transact SQL, we have window function, which you will use for your approximately 90% of data analysis functionalities queries. Okay, we just need to simply write over. That's all. So when you run it, so you see, I'm not going to write group by here. I've just removed group by from my query to make things really simple. So the case here is this window function will help you to get the total of line total column based on all rows in this query. But I don't want to get this duplicate data. I want to get data based on, I don't know, carrier tracking number or even my any other column. That's why we have partition by carrier tracking number. Let me just simply copy this from here, paste it here. Okay, that's cool. Let's execute it. So now we are able to partition this total sum number based on carrier tracking number. Okay, we are not going to see the same number for all carrier tracking numbers. That's great. So you see we have the carrier tracking number. Even in this case, you see we have 1, 2, 3, 4 duplicate carrier tracking number, and total sum for carrier tracking numbers for this carrier tracking number is going to be this number. Okay, but what if I want to see how this query ended with this result? and that's why I am able to provide another query element here, and it is called order by. Let me do it in this way, like this, to simply follow this stuff. Okay? And I will provide line total. I just want to see the result, the total result, but I want to understand how SQL get this total result. That's why we are able to provide order by. Let me execute this query. So here you see, and let me just provide this line total here, execute. So let's take this carrier tracking number. The first number was 6847, okay? And the next number is different. They are similar, but these numbers are different. Why? Because when you sum this amount of line total with this amount of line total, you will end up with this amount of line total. Same is applicable for the next one. So when you sum this one with this and this, you are getting this one. That's how we are applying our Transact SQL built-in window functions to aggregate our data to calculate the complex information like this. Okay, and this is applicable only within a same carrier tracking number. So you see, when you sum all these same 4, 1, 2, 3, 4 carrier tracking numbers line total, you will end up with this value. And then for the next carrier tracking number, we are starting everything from scratch, and it will show you. So you see we have only one row here, and let me show you two rows. Yeah, we have 3376, same as here, but when you sum these two values, you will end up with this value. That's how our window function is working. We can use AVG over partition by, order by, sum, mean, max, count, all these aggregate functions you are able to use within your Transact SQL's window functions. Okay, I think this is one of the greatest invention Transact SQL to write this sort of grouping data functionality without using group by. So in the classical manner, you are sticking to group by. If you want to get aggregated data, you should write group by. But these sort of queries will help you. Window functions will help you to get rid of group by. Okay. Well, that's simply all. I guess that's all from my side. I've tried to cover the essentials of Transact SQL functions. If you have any questions, please ask.
Okay, thank you very much, Tural, for
Thank you.
keeping our time frame. It's really, I truly appreciate it. So here we have two questions in chat box.
Okay.
The first one is, what about permissions? Can DBA.user use your functions, or you need to grant permission to it? This is the first question. And the second one is, which version of SQL is supporting window function? I have a client that has a very old version, 2008. These are the questions.
They are really cool questions. So let's start from the first one. Okay. When you wrap your queries into Transact SQL views, functions, store procedures, and when you make them as objects in your system, you can easily manage access based on rules. For example, I want my user to run this query. My user should be able to run this query, but another user should not be able to run the get sales order detail info query. So writing queries inside objects like views, functions, store procedures will help you to manage them by user, by roles easily. Okay, it depends from your database administrator how to configure and provide roles. That's simply it. But from the querying perspective, from the data analysis perspective, I guess I'm not let's say I'm not good in data analysis, but I hope in your case this is not your responsibility to provide the rule stuff. So you just simply need to focus on the exact queries to avoid repetition, to write really cool queries that are reusable rather than focusing on roles, but base it on database objects. You can easily provide roles which user able to run it or not. For the second query, I actually don't know the exact version, but for 2005, I think it is not working. Maybe if starting from 2008 or 2011, so I exactly don't remember the years, but you can easily check on internet starting from which version window functions are available. But as far as I see, the most popular data analytics functions from the Transact SQL side, they are windowed functions and aggregate functions. I hope these are the answers to your questions. Any other questions?
No, sorry, I was muted. Thank you very much for your answers. Two more questions. The
Okay.
next one is how about creating SQL indexing? This is
Mm.
next question.
Yeah. You can easily, of course, in Transact SQL function side, we are able to provide query optimization regarding your indexes. That's also easily possible. And also from the first things first, you should focus on your table optimization rather than directly function optimization, because function is just a virtual wrapper over your table queries. Okay, so this is not about functions. This is about underlying tables. You should design your table properly. You should check which columns you are extensively using to provide indexes for them. And in this case, easily wrapping them into functions will avoid any sort of optimization issues. So just simply focus on tables rather than functions. Okay, that's my answer to your question. And also, one more thing I forgot to mention, that for your views, for your functions, you are able to provide additional validations, like not to provide any different schemas. So they are internals of Transact SQL functions. We have a lot of sub topics related to Transact SQL functions, but in the general, I hope the things I have demonstrated here, like table valid functions and scalar functions, should be enough for now. Yeah.
Okay, thank you, Tural. Actually, we have some more time, like 5 minutes, so on and so
Okay.
forth. So, if there's any question, please be so kind as to ask or type your question. But while people are thinking, I would like to, ask you a little bit about the functions that we can use for data analysis in retail. I mean, let's say that. So, for example, we are interested in, getting data like year-on-year growth in our data set. Is it possible to show in SQL? I know it's possible, but what would you add about it? I hope my question is
I actually didn't get
understandable.
it. Could you please
You
repeat
did.
what type of queries you're
Okay.
looking for?
Okay. For example, let's say that just a minute. Let's say that we have a retail dashboard. I mean, say in a retail dashboard, I need to display year over year,
Um,
say in total revenue. So, what kind of T-SQL query? I mean, using window functions,
yeah, in
I
Transact
can
SQL,
yes,
yeah, I
to
hope I
calculate this
understand
growth.
your
Yes.
query. Yeah. In
Yes.
our case, as I mentioned, in Transact SQL, we have catalog of built-in functions, and one of them is called date and time functions. I hope you mean this type of
Yeah.
functions. For example, we have here your function. If you want to extract, let me show you right now the sales order detail. Okay. I don't know why I really love this table. Sales order detail table. So you see in the detail we have modified year. I want modified date, sorry. I want to extract only year from this. So I don't need to write my own year function. So it is easily, you can extract it like this. We have also month. We have also day. You can easily use these functionalities. And also, if you want to get the differences between your datetime, they are actually also mostly used in data analysis. For example, I have modified date. Okay, let me run this query. And I want to understand the differences from this modified date till now. Okay, so I can easily add the date difference between modified date and my current date. I'm actually not a big fan of using get date. For me, the sys date time is better than that because it is date time two rather than the default date time. But actually, you can use the get date for now also. Okay. And I have the first argument is going to be the interval. My interval is going to be year, the difference in year. Okay, so I have 13 years of a difference in month. Okay, let's just simply provide, I don't know, carrier tracking number maybe here. Okay, and let's simply run this query. Cool. So you see, we have, this is our month difference as div in month. So you have everything built in. You don't need to struggle with all sort of date time differences, especially the important stuff here is we approximately have all sort of date time problem solving functionalities like date add, you can add date, like you can add year, you can add, I don't know, months, day. You can easily find date difference. You can extract the exact date, time, depending from your function. I hope this was the answer for your question, Ilgar.
Yes, yes, yes. Thank you. Thank you very much. I really appreciate. If
Thanks.
there is any question, please ask. If not, actually, only 3 or 4 minutes have been left. We can wrap up. I mean, end the session. So more people thank you, Tral, for your perfect
Thank you
explanation,
very
for your
much for
time,
all
for
for
your
joining.
effort. Yeah, I really appreciate it. As I mentioned early in the beginning of my, I mean, this session is going to be, recorded. I mean, going to be shared on my YouTube channel. Also, the link will be shared with you in, Meetup group chat. So once again, thank you. So I'm going to just stop recording. So with your permission, let me stop. Okay, so